Alrighty, 28.27. Two very long insulated wires perpendicular to each other carry currents as shown. So we have one this way and one this way. Find the magnitude of the net magnetic field these wires produce at points P, which is here, and Q, which is here, if the 10 amp current is to the right or to the left. So we have 12 amps going up this wire, and then 10 amps going to the right or to the left in this wire, depending for part A and point B. This distance here is 8 centimeters. This distance here is 15 centimeters. And it's the same for point Q. Okay. So, magnetic field for a current carrying wire is mu naught I over 2 pi r. So that is the axial distance from the wire. So for a 12 amp wire, that's going to be 15 centimeters to get to point Q, and also 15 centimeters to get to point P. So the magnitude of the field is going to be the same for both points P and Q. So I'm going to find that right now. So our mu naught is 4 pi times 10 to the negative 7. I can't remember the units, so I'm not going to write them. 12 amps over 2 pi, and our R is 15 centimeters. So if I plug that into my handy dandy calculator, that doesn't belong to me, so if you still know who Michelle Zhang is, please let her know I still have her calculator an entire quarter later. Otherwise, I have a sweet new calculator. It's going to be great. Times 0.15. Kaplow. So 1.6 times 10 to the minus 5 Teslas is for our vertical wire. So for our horizontal wire, our mu naught I over 2 pi r. So now this one is 8 centimeters away from both points P and Q. So we've got 4 pi times 10 to the minus 7 times 10 amps over 2 pi r, which is 8 centimeters. Blah, blah, blah. So I'm going to take this thing, so this is 0.08 centimeters now. And this is 10 amps now. Blah. So that's 2.5 times 10 to the minus 5 Tesla. Okay, so those are our magnitudes. Now we want to look at direction. Okay, so now we need to figure out the direction. So my 12 amp wire is going up the page. So from my thumb, everywhere on the right side is going to be into the page. And everywhere on the left side is going to be out of the page. For my 10 amp wire, as I'm going to the right, everywhere above it is going to be coming out of the page, and everywhere below it is going to be going into the page. Oh, geez. All right. So here at point P, my 12 amp wire is into the page. My 10 amp wire is into the page. So those are going to add together. So that's going to give me 4.1 times 10 to the minus 5 Tesla. At point Q, my 12 amps are coming out, and my 10 amps are also coming out because we're above that wire. So it's also going to be 4.1 times 10 to the 5th Tesla. This one's going to be out of the page, and at point P, it's going to be into the page. Alright, so if my current is flowing the other direction in that wire, these directions are going to switch. So now they're going to subtract instead. So at point P, my 12 amps are going into the page, and my 10 amps are coming out of the page. So that's going to give me the difference, 1.6 minus 2.5. So 0.9 times 10 to the minus 5 Tesla. My out of the page is stronger, so it's going to win. So that's out of the page. And at point Q, my 12 amps are coming out of the page. and 10 amps are going into the page. So it's going to be 0.9 times 10 to the minus 5 Tesla into the page.